The previous slide is just an illustration of what to expect in shapeshift. In this section, we will be focusing on scale shifts. First, we may examine scale shifts graphically. To do this, we need to produce several quantile regression coefficients for various values of the quantiles. On the y-axis, we plot beta hat p, and on the x-axis, we plot the quantiles. When we examine shapeshift, we may be faced with the following situations. This will be how to interpret them. When we see a horizontal line, there is no scale shift. We only have a location shift for a corresponding unit increase in the predictor variable. When we see an upward sloping curve, there is an increase in scale for a unit increase in the predictor variable. And last but not the least, when we see a downward sloping curve, there is a decrease in scale for a unit increase in the predictor variable. This is an example of how to examine scale shift graphically. Suppose we have a model and we are modeling the dependent variable income in US dollars with two independent variables, ED, or the number of years of education, and white, a dummy variable where white equals 1 when the individual is white and 0 if the individual is black. First, we look at the predictor variable ED. Since the graph is sloping up, there is scale shift, and we can interpret this as an additional year of education increases the scale of income in US dollars. This is because we can see that the pattern is sloping up. Next, we look at the plot for the predictor variable white. Since the graph is sloping up, there is scale shift, and we can interpret this as changing the race from black to white increases the scale of income in US dollars. In general, education and race are responsible for location shifts and scale shifts because their graphs are not horizontal. So as you can see here, both of their graphs again are sloping up. You might also notice that there are horizontal black lines here at y equals 0. Since the plot of the quantile coefficients do not touch this line, this means that the quantile coefficients are significant. So this black line here only shows whether our estimated coefficients are significant. Meanwhile, this gray area here that we can see surrounding our black lines are the bootstrap 95 confidence envelope. The graphical view, however, does not quantify scale shift and its significance. Also, the graphical method is not able to show skewness shift. To quantify scale shift, we can compare a comparison group and a reference group that share the same median M. The steps are as follows. So for the first approach, we use the sample quantiles directly from the samples in the two groups. You do not need to perform quantile regression modeling in this approach. Simply compute for the interquartile range for the reference group and the interquartile range for the comparison group. Then compute for the difference in IQR of the comparison group and the IQR of the reference group. This difference is a measure of scale shift. Now, the second or alternative approach uses the estimated coefficients generated from quantile regression model. So, dito natin magagamit yung beta hat coefficients ng quantile regression. The pth scale shift effect is denoted by SES of P, where SES of P is computed using beta hat 1 minus P minus beta hat of P. Now, why are we subtracting beta hat 1 minus P and beta hat P? Recall that we interpret beta hat P as the estimated change in the pth quantile of the distribution, corresponding to a unit change in the continuous variable xi holding all other regressors fixed. Thus, when we increase the predictor variable xi holding all other regressors fixed, the corresponding pth interquantile range changes by the amount beta hat 1 minus P minus beta hat P. So, to interpret scale change, we consider three cases. For the first case, when SES of P is equal to 0, there is no evidence of scale change. If SES of P is greater than 0, we interpret it as a unit increase in the predictor variable results in an increase in scale. Meanwhile, if SCSFP is negative, a unit increase in the predictor variable results in a decrease in scale. Note that, again, the first approach uses quantiles, while the second approach uses the coefficients from quantile regression. Now, let us look at this example. We shall examine scale shifts of income distribution in dollars from 11-year to 12-year education. The reference group is the group with 11 years of education, while the comparison group is a group with 12 years of education. On the first column, we computed for the sample quantiles. And on the second column and the third column, we can see the sample quantiles for both groups. Next, we focus on this part, the Q.75 minus Q.25. This is the interquartile range. So for both groups, we computed for the interquartile range. For 11 years of education, we have $26,426. So this is in US dollars. And for education equals 12, we have $34,426. So, using the first approach, scale shift can be obtained by computing the difference between these two. So, we can see that from 11 years to 12 years of education, the interquartile range increased by $8,000. So, ito yung measure natin for scale shift. Now, you might ask, ano naman ang kinalaman ng mga other interquantile ranges here below? So, take note, hindi siya interquartile, it is interquantile range. And how can we interpret this? So, for the interquantile ranges, the scale increase is $15,422 for the middle 80% of the sample. So, dito siya nanggaling. And why 80%? Because ang difference nitong Q.90 and Q.10, sakop niya yung 80% nung sample natin. So, for the remaining, we have 19,736 for the middle. This time, 90% of the sample. Dito naman siya nanggaling. And for the last one, we have 28,052 for the middle, 95% of the sample, which also came from here. Now, using the second approach, or the model-based approach here, we look at the differences in the beta hat coefficients below. So, the scale shift brought about by one more year of schooling in the middle 50% of the population is 3,426. Ito yung beta hat 0.75 minus beta hat 0.25. Next, we have for the middle 80% of the population, the scale shift brought about by one more year of schooling is 6,497. And for the middle 90% of the population, it is $8,445. This is the scale shift brought about by one more year of schooling. Now, you might ask, why are the values computed from the first approach different from the values computed at the second approach? So, makikita naman talaga natin, it is very obvious na itong value na to different siya from this, and the succeeding values are also not equal. Specifically, you might ask, bakit din mas mataas ang values from this first approach than this second approach? So, this model-based measure is a partial measure that also controls for the other predictor variables. In this case, the other variable is a dummy variable white. Meanwhile, the scale shift based on sample quantiles is specific for the two education groups na specify natin. So, education equals 11 and education equals 12. Although they are not equal, both are actually useful for measuring scale shift computationally.